All right, looking at our next example, number 5, we can see that the denominators are both monomials. And so that's going to create a unique LCD. Our LCD is going to need to have all the factors and the highest exponent shown of any of the variables. So I need the number 5 times, I need the number 4. So I always do the numbers first, then I'm going to do the variables. So I've got x to the 3rd here. This is just x to the 1st. So x to the 1st is inside of x to the 3rd. So I need x to the 3rd in my LCD. And then I see the y to the 2nd, that needs to be in my LCD. There's nothing to compare it to. So my LCD is really 20 x to the 3rd y squared. So in order to create that LCD, I'm coming back to my original, and I have 5. And so I need to multiply by 4 y to the 2nd on top and bottom. On the other side, the 4, I'll times that by 5. And I have x, then I need to get to x to the 3rd. So I need 2 more x's, x to the 2nd power. So altogether, that's going to be the denominator 20 x to the 3rd y squared. And 6 times 4 is 24 y squared, plus 5 times 25 is 125 x squared. I'm looking to see if both the terms in the numerator have a factor, but I don't think they do. So this is fully simplified. And in terms of our restrictions, x does not equal 0 and y does not equal 0. I forgot about that because they're monomials and they're just being multiplied. So if x was 0, the denominator would be 0. And if y was 0, the denominator would be 0. And those are our excluded values. Got a couple more examples. That one's kind of neat. So here I've got example number 6. It's another addition problem. That's great. And I see that the two denominators both have x and 1, but they are binomials. So this is like the word cart, and this is like the word, well, maybe it has an A in it, art. And so art and cart are not the exact same word. If you add a C and then the word art, yes, it does sound like cart, but you would say see the art, see some art, you know, whatever. So in this case, my LCD is going to contain both factors. Because if I was to times, oh, that's why. Because if I times this by 3, remember the distributive property, and of course it's not going to change the positive to a negative. So my LCD, oh, hello, is 3x minus 1 times x plus 1. And so my excluded values are x does not equal 1/3 or -1. Just keeping that in mind right away. So this one's actually kind of easy. I just need to multiply by the other factor. And this one needs x plus 1. But I do notice that I'm going to need to FOIL in the numerators. So I'm just going to work on the numerators only right now. And I'm going to do first, outside, inside, last. So x squared plus 8x plus 1x plus 8, and then plus, so I'm really happy about that. I don't need to use the brackets. And then I'm going to do the same thing over here. First, outside, inside, last. 3x squared minus x plus 9x minus 3. Now I combine my like terms. 4x squared. 8 and 1 is 9, plus 9 is 18, minus 1 is 17. And then 8 minus 3 is positive 5. I want to check to see if that factors. So my little side work is 20 and 17. So I've got 10 and 2. That doesn't add to 17. 1 and 20, nope. And 4 and 5, nope. So it doesn't factor any further. So my denominator is 3x minus 1 times x plus 1. Final answer. Very cool. Here is our last example. Is it? Yes. Number 7. So this one is minus, so I'm going to keep that in mind right away, that I'm going to need to use the brackets, and I see that the denominators are trinomials that need to be factored. So I'm going to factor them. Multiplies to 6 and adds to negative 5. Multiplies to negative 12, x plus 4, x minus 3. So my LCD is going to contain all of the factors in the denominator. So they both have x minus 3, so I need to include the x minus 3. And that's the one that they have in common, and now I need to include the other factors, x plus 4 and x minus 2. Oh, I wrote way too big. So this one I also don't mind too much because I'm noticing that the numerators I'm not going to need to really FOIL. So the first term is missing the x plus 4. And when I distribute that, I'm going to have 4x plus 16. Then I'm going to put the minus, and I'm going to use the bracket for the second term because I see that minus sign here, and I just want to make sure to include it, and it's going to subtract the entire term. And that's just something where we sometimes make mistakes, so I just really want to slow down so that I don't make an error. So I've got to multiply the second term by x minus 2 because that's missing. And when I do that, I've got 5x minus 10. So because I'm subtracting this, now I distribute. And I have negative 5x plus 10. And now I feel comfortable to combine my like terms. So 4x minus 5x is negative x, plus 16 and 10 is 26. All over the long denominator, x minus 2, x minus 3, and x plus 4. You know what I forgot about are my restrictions. X does not equal 2, 3, or negative 4. And that's it for these notes. Let's take a look at some practice problems and maybe see some more unique situations. Remember to ask questions and look at the answer key.